Hello guys, today we will see stack implementation through vector. So in today's video we are going to implement a stack using STL containers. So through STL we will implement a stack in C++ programming. So I'll write basic code and also we'll see some basic use stack function which were provided by C++ in C++. They provide us in STL. We'll go through one by one. First will be stack push function. These all we'll discuss one by one. Let me write all those names, table of content you as I write. Second will be pop function. Third will be empty function. Fourth will be size function. Okay, so push, pop, empty, size, and fifth will be top function. Sixth will be swap function. And also some places we see amplace function that is similar to first one push function. So that also we will check it out. Suppose you see this using amplace in somewhere online in some codes, so you can understand there's no difference between them, just a keyword difference. So let me start as include IOStream using space standard into main. Okay, so whenever we are going to implement a stack, we have some basic idea about the stack, how stacks work. So the general idea about the stack. Okay, so what it's showing error as inquiry, please update or include path. Let me run a basic check if there is an error or not. Let me run it. Okay, IOStream compilation terminated. Okay, so IOStream, sorry, I just got confused. Okay, so before implementing a stack, we just check out what are the basic functions we use, why we use a stack. So in the stack, it's like a bucket, like a bookshelf. In bookshelf, like a stack of books, you put one book on another book. So like that, in suppose you have a bucket, in that bucket you first inside you post one book you throw inside your bucket. So like suppose first I book fifth number book I pushed into bucket, then I given fourth number book, then I third. So like in bucket you can't take directly from the bottom of the bucket, you have to take it from one by one, from top to bottom approach, like top to bottom you have to go. So here in stack we also say it first last in first out, leaf order. Okay, so last in first out, leaf order. So stack follow this order. Those who come last, they will be first, they will be get chance to leave first. Suppose like you have a jar, small jar, in that you can only put two, like the area circular jar, in that you at a time you can put one ball inside it. Okay, so like this you can put 5 ball inside a jar. So you can't take the first ball at bottom, you have to take first uppermost ball, then second uppermost ball, then like that you can take last ball. So like that here, like I first put at 5, then 4, then third. So now I can remove third only in first try. Second try, after removing third I can remove 4, after removing 4 I can remove 5. So like last in first out, here third comes last, leaving it first. Okay, so like that it follow. Same implementation will go like vector, we will implement some basic practices how to use these functions. So let me create for a stack. Whenever you want to initialize a stack, you have to write a stack, then data type. Okay, after that you just write the stack name. Okay, this will be a basic implementation of stack. Okay, then semicolon. So I'll create my first stack with the integer data type. My stack name will be st. Okay, let me add bits slash stem.c++. Okay, stack integer, and then I want to push first st.push. Same example we'll take here, like first I put at 5, then 4, then 3, and thereafter 3 will leave first, 4 will leave second, and 5 will leave third. Okay, so first 3 should be print out, second 4, third 5. So I am let me comment these lines. Okay, so st.push, first I'll push 5, then I'll push 4, then I'll push 3. So here we have two methods to print a value. Like while going we'll implement other methods. So like first I put at 3 values. So how can I print these values? So first we'll check, we have two iterative methods. One will be first will be let me comment out and write here. First will be through for loop and second will be through while loop. We'll try both the scenarios. Okay, so first we'll go with while loop. So I'll make a condition while, okay, st.empty. Okay, so what it will give me? If stack is empty, then it will print yes. If not, then no. Now I'll put not equal to here. So suppose if my stack is not empty, means it will say me no, and not equal to will convert it into yes. Okay, so it will reverse, and until my stack empty, while will go, and during the while will go, I'll use int val equal to now. How can I access a value inside a stack? So to access any value inside a stack, you have to use top function, stack top function. Okay, stack top function. This you have to use every time. Okay, so whenever you want to access any value inside a stack, you have to use stack top function. So I'll here st.top, because in a stack we can see only uppermost value. We can't see what values are below that. We can check only the last value on the stack which we have just now filled. So like that I put it st.top. It will give me uppermost value of a stack. Then if you want to remove anything from your stack, you can use pop function. Okay, st.pop. So here one thing also, suppose if I come and see out, I just printed my val and I not implemented this value, then my while loop will be infinite, because stack will never go empty. It will always read the uppermost value, and that is 3. It will never stop. So to stop it, we have to use st.pop. Okay, so pop, what pop will do? It will remove first element from this stack. Okay, so it will remove first element from this stack. Wait, where is undefined? Okay, forget it. So it will remove first, like first I printed 3, I taken the value 3 into val, then I'll remove 3. then I'll print 4, I remove 4, then I print 5, I'll remove. Okay, like that. So one second. Okay, so it will print. Let us check whether it's working or not. Return 0. So 3 4 5. What we have written? First we pushed 5, then 3, then 4. So like, let me use this pen. Like, you have a bucket, you first put it 5 inside this, then put it 4 inside this, then put it 3 inside this. So you only see from top, you can only see 3. Like, this can be a top and you are able to see only 3. You can't able to see what is behind this. So you can only remove this one or see this one. You have only one option. Okay, so like this, first 5, then 4, then 3, and you are using a stack until the stack you are using here stack dot empty not equal to. Okay, so I'll make it also not here, that I'll see out whether my stack is empty or not. Stack dot empty, it will give me enter. Okay, so I'll print it 2 times. One before I have anything I pushing into stack, and one after pushing into stack. Okay, so before pushing a stack, 1 means your stack is empty. After pushing values, it's showing me 0 means your stack is not empty. And here I am checking condition. Until my stack is not empty, you run this while loop, and in while loop I am assigning the topmost value of a stack to a variable. And after once assign value to variable, I am taking out value from stack and printing that value from variable and iterating until my stack got empty. Okay, so same thing you can also do with for loop. For for loop, like before going to for loop, let me show you one other example. Stack dot size. Okay, so it will return you size of your stack. Like here it's showing me size of my stack is 3. This one is 4. My stack is empty or not, I'll comment it out again. Okay, so you will get better this idea. So I have 3 elements. So for loop, you all know, like basic, I can initialize I0 until st dot size I plus plus. Okay, and here what I will do, same thing, integer value equal to st dot top, st dot pop. I'll remove the value, I print the value, see out where. Okay, so nothing different, same thing, whatever we done here, similar thing we done here. It's not relative, just here we are checking to empty function until my stack is empty. Here I got the number of size, how many values I have inside a stack. Based on that I am iterating over loop, no difference among them. Okay, and also like these 3 things I can do instead of push. I can same these 3 things I can do with emplace. There is no difference. Emplace. Okay, let me run it again. 3 4. Okay, 5 not printed. One second. What size here? 3. Okay, now therefore 2 values is printing. So we'll iterate. First I will be 0, I less than stack dot size, that is 3, I plus plus. I have taken topmost value, that is 3, stack dot pop. I remove 3 from stack, I am printing 3. I will be 1, 1 is less than 3. Okay, stack top. I taken 4 from stack, I remove from stack, and I'm printing 4. Then my I will be 2. 2 is less than 3. I am again taking value from top of stack, popping it out, value. Okay, all fine. 3, 4. Okay, let me check out here. What's the issue? It's showing 3 values you have inside. Let me also see out my I. So till what time I is running? 3041. For 2 it's not running. Okay, I have to put here equal to. Okay, I got an. So here, whenever we pop something from a stack, it's decreasing the size of a stack. So we are not know what is the exact size of our stack, but we are incrementing it. So to avoid this, we can use like integer, declare a variable n with st.size. Okay, sorry. And here you can use, instead of this you can use n. Okay, so you'll run it 345. Okay, and similar if you want to, like, why this got issue, that is very simple, that whenever you use stack.size here, every time it check condition. Whenever my I increments, it will check condition about whether what will be my stack size, and based on that it will compare I is less than of that or not. So to avoid this scenario, we mostly prefer while loop. But yeah, here you can also do like I is less than, instead of this I plus plus, remove it. Okay, same thing you can achieve. 345. Okay, so far we have seen push function, we have completed pop function, how to push into stack. I'll write here pushing value into stack, popping value from stack. Okay, empty will let us know whether stack is empty or not. And size will tell our stack size. Top will tell topmost element of a stack. Topmost element of stack. Swap we have to see. Emplace is same as push. Okay, so now we'll see top swap. So suppose I have one stack 345, and same time I also have I declared a stack integer, that name is s. Okay, so here I am pushing s dot push 1. Now my s stack have, and I have st and s. Okay, so in st I have 3, in s I have 1. Okay, and 4 and 5. Okay, these two values I have st and s. So what I want is, I want to shift all values of st to s, and all values of s to st. How I will do it? Let me show you. I'll declare here swap, okay, st comma s. It will swap both these stacks. Okay, so suppose I am taking here value of st. Previously we know that in st we have 345, but now here it will print only 1 because I swap both of them. Let me run it. 1. Suppose if I push here with 1, I'll push 4 and 9. So we will get 149,941. How? Because 9 goes last, then 4, then 1. And in a stack we know last in, first out. So 9 inserted last and first 1 inserted at first. Okay. So we also see swap function of a stack. Swapping two stack values. Okay, so that's it for all. These are the stack function that we are using inside our programming, and for CPU also. These are the stack features, you can call it functions, which were provided by STL library in C++. And thank you guys for watching this video. Please like, share and subscribe. Also, if you want any specific topic, please comment below. I'll make a video on that topic. Thank you guys.